Okay, in this example, we're going to look at the area between two curves. And there could be multiple curves. It doesn't have to be two, but you want the area between them. Alrighty. Now, this one's fairly nice because they give you these bounds. I know I'm going from -1 to 1. So let's do a rough sketch, but I'm going to explain how maybe you could get away without even sketching these if you were unsure what the graph looked like, or just being lazy, I guess. So again, we could do a table of values, but a parabola, this has a shift up 1 and it opens up, right? So very rough sketch. I know that one does that. This is also a parabola, but it got shifted down 1 and it opens down. So down 1 and it opens down. So therefore the area that is being asked of us is between -1 to 1 here, right? This area in here. Okay. So we found area between the x-axis and a curve. If it's above the x-axis, we could just integrate. And if it's below, we had to flip it to a negative. Well, it turns out we don't really care between curves if it's positive or negative, because what you do is you integrate and you subtract the functions. Okay, you want the upper curve, subtract the lower curve, and what will happen is this negative area down here becomes positive. This down here becomes positive because when we subtract, it flips a sign. A quick rough sketch of something else. Two other functions, suppose they were both above the x-axis, whatever they're doing, doesn't matter. Right? If I found the area below this one, I would have all of this stuff. And then when I subtract the area of this one below, right between the x-axis, I would get the area between the two curves. So what we do is we take this upper function, whatever it is, and we subtract this lower function, whatever it is, and we integrate from our bounds. So with that said, we go from -1 to 1 here. Upper curve, right, this is f. We have x squared plus 1. Subtract the lower curve, -x squared minus 1. And integrate. If you can, it's always easiest to simplify before integrating. A little less work, but sometimes they won't combine, and that's okay. Go ahead and do your integral. So we have, let's see, x squared and a negative x squared, 2x squared. 1 minus 1, right? Yeah, so that's 2. -1 to 1 dx. Integrate, we have 2x to the third over 3 plus 2x from -1 to 1. Okay. Substitute 1, we would have 1 cubed is 1, so we have 2/3 plus 2 minus, substitute -1, that'd be a -2/3 and minus 2. Both of those signs will change, so we'd have 2 plus 2 is 4, and 2/3 plus 2/3 is 4/3. Last, getting this LCD, that would be 12/3, so 16/3. Again, whatever the unit is squared, since we are in area. Okay, quick side note, if we did this problem and either we graphed it wrong, or on the other hand, even, I don't even need the graph. They give me the bounds here. I'm just going to guess and subtract. If these two were out of order, okay, you had the wrong upper curve. You'd flip F and G. All that would happen is your final result would be a negative. So one thing we could say is, integrate it, f minus g, and be sure to do the absolute value, and that will work for these bounds. Okay. When these curves intersect, we gotta think about it slightly different, but for this one, you know, if you got a negative, switch to positive, it should be good.